It's Halloween, 1961. 10 of the world's leading scientists have found their way to a remote spot in the Allegheny Mountains. They're there in secret to talk about searching for aliens. Okay, hang on. This isn't the beginning of a Twilight Zone episode. This meeting actually happened. Not only that, this secret meeting would eventually change the way we think of our place in the cosmos. And it's all because of a man named Frank Drake.
Our best evidence would suggest that there is a very large number of planetary systems in our galaxy, possibly some 50% of the stars have them. Well, given a planetary system, will there be life on it?
That's Frank Drake, a year earlier, at a different meeting in 1960 at Colgate University. He's an impossibly young, 28-year-old astronomer, speaking to a room full of physicists. But what's even more impossible is the question he's asking. Are we alone in the universe? At the time, this wasn't a question scientists were comfortable asking, at least not out loud.
I think I'm here to provide the comic relief to this shindig.
Frank knew his audience. He knew this question would make them squirm, even giggle. But he also knew he had to ask it.
The question as to whether there is intelligent life elsewhere in space has long fascinated people.
Just how long people have been wondering about life out there is anyone's guess. Looking up into the vast ocean of stars has made us wonder since, well, forever. But as Frank addressed that group of physicists in 1960, the question still hadn't been given any serious scientific attention.
But has been properly left to the science fiction writers and other non-scientific groups simply because our technology was not capable of detecting any reasonable manifestation that could be expected from other civilized communities in space.
The infinite magnitude of space that daunted and even terrified so many others at the time appeared observable to Frank. What's more, he asked others to observe it with him.
In recent years, our astrophysical knowledge of the universe and our technology has advanced to the state where these questions can no longer be ignored by the scientists.
And Frank Drake was one scientist who would no longer ignore it. In fact, at that very moment, he was on the cusp of the first ever scientific search for extraterrestrial intelligence. Out at that remote site in the Allegheny Mountains, at a place called the National Radio Astronomy Observatory in Green Bank, West Virginia, it was a project that would challenge the boundary of what was considered unacceptable science.
So, this question of how many civilizations in space depends not only on the question of how many planets there are, but on another very important question, and that is there intelligent life on Earth?
Yeah, right. Fortunately, Frank Drake did find intelligent life on this planet, specifically 10 highly educated, rarefied beings who wondered if they too were alone in the universe. And they would gather at that observatory in Green Bank, West Virginia, the very next year on Halloween night. And our age-old question about our place in the universe would be given new meaning. I'm Peter Gwin, editor-at-large at National Geographic magazine, and you're listening to Overheard, a show where we eavesdrop on the wild conversations we have here at Nat Geo and follow them to the edges of our big, weird, beautiful world. This week, we're asking the big question, the one that pops into your head when you stare up into the night sky and wonder, are we alone? But don't worry, you're in good company. Frank Drake has been giving people the tools to ponder this question for decades, especially the people who are about to answer it. More right after the break. This summer, adventure's never far away with a free 1-month trial to National Geographic Digital. For starters, there's full access to our online stories, with new ones posted every day, plus every Nat Geo issue ever published in our digital archives. There's a whole lot more for subscribers, and you can check it all out for free at natgeo.com/explore more.
The question we got the most was, be real, we know you have aliens buried in your basement. Which, of course, We do not.
That's what I was getting at, Nadia. That's really the question I wanted to ask.
We do not have aliens in our basement that I am aware of.
Imagine being the daughter of not just a famous scientist, but the daughter of a famous scientist who's looking for aliens. That's what growing up was like for Frank Drake's daughter, Nadia Drake. She's a science journalist who writes for National Geographic.
Dad loves to tell stories, and so I always loved listening. Having a dad in astronomy meant that we could do backyard observing nights, and we would aim the telescope at the sky, and Jupiter was always his favorite to see because of the colors.
Nadia's dad, who recently celebrated his 92nd birthday, grew up on the south side of Chicago. The middle of a major city might seem like an odd place to look at the stars, but it was actually an ideal place for a budding young astronomer like Frank.
We would go to the Adler Planetarium, and they had the big demonstrations that they ran in the planetarium where they could describe the constellations and things like that. We did that by bicycle.
It was there that he started to imagine the possibility of life outside our planet. And later, as a sophomore at Cornell, he looked into the night sky and saw it revealed everything.
I think the biggest thrill I ever had in all this business was the first time I looked at Jupiter through a pretty big telescope and actually saw the weather bands on Jupiter and the great red spot. And you could see the appearance of the surface of Jupiter was changing from hour to hour. It just struck me as spectacular because I had been reading descriptions of it and saw in pictures and books, but it's actually right there and you can see it.
This kid from Chicago peered into the cosmos and had a revelation.
And there's a lot of complicated things happening in the universe.
The universe presented itself as more than just an inky black cloak with tiny pinpricks of light, but rather as three-dimensional and colorful and limitless. He described it as a kind of Galilean moment.
And I thought that was just thrilling.
That thrill propelled Frank forward, a stint in the Navy, graduate school at Harvard, and then on to begin his career in astronomy, to pursue the question that had driven him since childhood.
Evidence for life in the universe would be found observing the planets of the solar system.
And that's really been his focus ever since. But in talking to Nadia, I was curious. How would an out-of-the-box thinking scientist describe such a quest to his young daughter? How did your dad explain how he would go about looking for alien life?
He said it's like looking for the technologies that we have. And to me, that was very easy to conceptualize. Just looking for signs that other civilizations have communicative technologies that are like ours. It's conceptually simple, right?
Yeah, it is, but it's also daunting. Okay, you can hear my hesitation here. What's simple for Frank and Nadia Drake, who, by the way, has her own PhD in genetics, is not necessarily simple for everyone. So let me break it down. Frank's strategy for detecting the existence of life on other planets involves picking up radio signals, which are a form of electromagnetic radiation. The idea here is that if a planet has life on it, and not just any life, but intelligent life, it also may possess the capability of using technologies like transmitting radio waves. For example, here on Earth, we've been broadcasting radio for more than a century. And each radio signal, long after it's transmitted, the baseball game, the news report, the Beatles song, keeps traveling on an epic journey through the universe. So Frank reasoned that if we on Earth could pick up radio signals from somewhere out there, it could indicate there's intelligent life on another planet. Of course, that's easier said than done. It is, but it's also daunting. It feels like that needle in the haystack kind of situation,
yeah.
Except for the haystack is the universe,
Yeah, that's all. Yeah, that is the crux of the problem, isn't it? The haystack is massive.
Yeah.
And
Infinite.
That's what SETI scientists are up against all the time.
The scientific field Nadia is referring to is known as SETI, which is shorthand for the search for extraterrestrial intelligence. Okay, so getting back to that haystack, just how massive is it? Well, here's one way to understand how much of it we actually know.
So imagine somebody says to you, hey man, are there fish in the ocean? And you go out and scoop up a hot tub's worth of the ocean and you look and they're like, there's no fish in here. And so therefore there's no fish in the ocean. I know that for sure.
This is Adam Frank. He's an author and professor of astrophysics at the University of Rochester. And he's referring to a paper by his colleague, Jason Wright, who figured out that, if the entire universe is the ocean, so far we've searched a tiny fraction of it.
So you often hear people saying, like, we've been searching for aliens for 50 years and we haven't found anything, therefore we know they don't exist. But that is malarkey, as we would say.
There are few areas of science that provoke such strong opinions as looking for life outside our planet. Even the ancient Greeks argued about it. Aristotle held on to the idea that we were the center of the universe, and Democritus said, no, there must be other forms of life out there. And that was more than 2,000 years ago. But the argument continues. More recently, skeptical reactions often take the form of nervous laughter. SETI scientists have a name for it. They call it the giggle factor. It's someone's way of saying, you don't actually believe in aliens, do you? Ha 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 ha. But then Frank Drake comes along, and he's got this idea about radio waves. Okay, it's 1958. The ink is barely dry on his PhD when Frank gets a job as a staff astronomer and head of telescope operations at a brand new radio observatory way out in Green Bank, West Virginia. By his account, he was only the fifth or sixth person with a PhD in this field. And that's because radio astronomy was just taking off in the late 1950s. It was groundbreaking for its ability to reveal the unseeable characteristics of, almost everything that's out there. Supernovas, quasars, nebulae, and astronomers still use it today.
Radio waves, actually, they move differently through the cosmos than optical wavelengths do. They're better at traveling through interstellar dust, gas, all the stuff that tends to be a problem for optical astronomers.
In Green Bank, Frank helped build a radio telescope with an 85-foot receiving dish, and it was a big moment for this new field. But Frank was excited for another reason as well. This thing might just be large enough for a serious search for extraterrestrial intelligence.
And everybody's like, oh, we're going to look at galaxies. No, I want to look at supernova. And he has to convince his colleagues that, maybe we should look for aliens, right? But what's awesome is they were like, okay, because he had what Frank Drake had, and this is what makes it so important. He had a plan, right? He did the science.
For 4 months, Frank set his alarm for 3 a.m. He climbed up into the giant telescope jutting above the forests in the Allegheny Mountains, and he searched for radio signals in the vicinity of 2 sun-like stars, each about 11 light-years away, Tau Ceti and Epsilon Eridani. He knew the stars were there, but he was only assuming that they had planets, and maybe, just maybe, that they'd have life on them. Okay, this was the longest of long shots, but he spent 6 hours a day toggling a 100 hertz channel receiver up and down the dial, searching for signs of life. He called it Project Ozma, after Princess Ozma from Frank Baum's Wizard of Oz series.
He was thinking of the worlds that he might find. He was imagining places like the Land of Oz that were populated by strange and exotic creatures.
As it turned out, Frank and his colleagues didn't pick up any broadcasts from alien creatures. They heard mostly static. But the search for life in outer space had begun.
So it was truly the first scientific search for life outside of Earth. It was groundbreaking. It was genius in a way, and truly heroic.
The National Academy of Sciences, which advises the U.S. government, took notice. Soon, Frank was approached by the organization, which had taken an interest in aliens since the Soviets had launched Sputnik 4 years earlier. The Cold War was well underway, and they wanted to gather absolutely every scientist with knowledge of this new field. Altogether, there were only 10 of them. Which brings us back to the secret Halloween meeting out at the Green Bank Observatory.
And that's where, in 1961, the Drake equation was unveiled for the first time.
The Drake equation. It would prove to be one of the most influential equations in astronomy and the starting point for SETI. The group of 10 included astrophysicists, astronomers, electronics inventors, and exobiology experts. Among their ranks were a young Carl Sagan, chemist Melvin Calvin, and Otto Struve, one of the most influential astronomers of the 20th century. So here's super young Frank Drake, who's now in charge of organizing this meeting with some scientific heavyweights. A meeting that poses this ginormous needle in the universe challenge. How do you even start?
He had all these people showing up, and he realized he did not have a meeting agenda, and he needed a way to organize their discussions over the next couple of days. And so that's how he ended up writing the Drake equation, completely casually. He ended up using that as his meeting agenda.
Okay, so scientific equations can feel pretty intimidating, but really, they're a way to break a complex question down to its parts. And in Frank's case, it offered the starting point for this big meeting.
The equation says N equals R star, F sub P, N sub E, F sub L, F sub I, F sub C, and then big L.
Okay, when you hear it like that, it sounds kind of like alien code. But when you put the whole thing together, it's actually just a thought experiment to solve a straightforward question.
It is just looking for the number of detectable civilizations in the Milky Way galaxy.
So he takes this impossible question and he breaks it into 7 sub-questions. Each one can be addressed separately.
It starts by asking, how many stars are formed each year in our galaxy? Seems reasonable, right?
Planets exist around stars, and so you want to know how often these places that support planets are emerging.
And then the equation makes its way along a string of variables, starting with exoplanets, planets outside of our solar system, which, P.S. in 1961, we hadn't even discovered a single one yet.
Because if you don't have planets, you're not going to have life. How many of those planets are in the habitable zone, are in the right place for life? How many have life forming? What fraction do you get actually life starting?
This is the number that we're currently trying to nail down. What is the fraction of life
evolve forward into intelligence?
What is the fraction of intelligent life that develops communicative technologies?
And then the last part of the equation, which is just L, ends with a bit of a curveball. It reminds us that life out there, like life here on Earth, is probably fleeting.
You basically just want to know, how much time do I have to find these things?
How long is a civilization detectable? Which also means, how long will we be around to detect it? The value of L was a heavy question for scientists who were smack dab in the middle of the Cold War and living under the threat of nuclear Armageddon. But taken all together, the equation became a kind of cosmic roadmap.
What it is really, in some sense, is a statement about our ignorance and how to undo that ignorance.
So, this group of brainiacs is all gathered at Green Bank discussing those 7 variables at length, variables that finally made the universe seem manageable, even if the answers weren't known. They worked hard, only pausing briefly for champagne when one of the attendees, Melvin Calvin, won the Nobel Prize for Chemistry. And they bonded. The feeling of community, as Frank called it, was one they wanted to continue. So they gave themselves a name, kind of like a secret society, because, well, it was pretty secret.
In the 1960s, looking for aliens was super fringe. I mean, it's still kind of fringe. But back then it was even more so. And so I wondered, too, like if people thought they were taking a risk by being there.
They called themselves the Order of the Dolphin, which was a nod to a member of the group who was studying communication with intelligent non-humans. And with their last bottle of champagne, Otto Struve made a toast to the value of L, the lifespan of civilizations. May it prove to be a very large number. In the 6 decades since the introduction of the Drake equation, there have been monumental advances in space research and exploration. Humans on the moon, deep space probes, space stations. And while SETI has seen some success, it certainly hasn't enjoyed the same progress.
So what's interesting is SETI has been starved for cash almost its entire life. And that's why, we're kind of in the state that we're in. So one thing, let's just step back and let's ask how much SETI has been done since Frank Drake. And the answer is almost none.
You could chalk that up to a matter of priorities. Moon landings and space shuttles took up much of NASA's attention. But two pivotal decades, the 80s and the 90s, saw major political objections to SETI. Aliens, as it were unpopular among elected officials. The seeming impossibility of SETI, a scientific rifle shot, as it was described, challenged lawmakers' political will. This was an effort that might take many decades before it found results. Senator William Proxmire ridiculed SETI as a fruitless attempt to search for little green men, and he gave it his infamous Golden Fleece Award for wasteful government spending. And in 1993, budget tightening and that giggle factor finally caught up with SETI, and its congressional funding was canceled. It often seems that the argument between the ancient Greeks is still going strong. But politics aside, our collective reluctance to search for life beyond our planet begs the question, why do you think we're so afraid of what's out there?
Oh my gosh, I think we've always been afraid of what's out there. The idea that we are the only inhabited world is actually scarier than finding out that we're not.
It's like the fear of what's out there overrides what I think your dad sort of embodied was the optimism or the wonder,
Mm-hmm.
But a lot of it is like, no, they're going to eat us, or they're going to strip mine our planet, or make us slaves or whatever it is.
It's interesting that in a lot of the science fiction stories, the aliens are never benevolent vegetarians. They're always out to, in some way, exploit us.
Our imagination and fear about space often has more to do with science fiction than it has to do with science. But the thing a lot of people don't understand about the rest of the universe is that it follows the laws of science that we already understand.
The interesting thing about science is that it is imagination constrained. Why? Because there's these things called the laws of physics and chemistry and biology. And when I learn the laws of physics and chemistry and biology, it tells me what I can imagine, what's consistent and what is constrained by reality.
In other words, according to Adam Frank, aliens may be weird, but they aren't magic. They're going to abide by the laws of science.
So the beauty of all the science we've learned over the last 400 years is that it allows us to think about and predict things that we haven't seen that we want to go look for. So yeah, that's how this process works.
And just as Frank Drake and so many astronomers anticipated decades ago, technological advancements have finally caught up with SETI. I'm talking about the discovery of those all-important exoplanets. Beginning in 2010, the Kepler Space Telescope, which NASA called the Planet Hunter, began finding planets everywhere. Thanks to Kepler and TESS, a survey satellite, the number of exoplanets recently shot past 5,000.
We know the galaxy is stuffed with planets. So right there, the probabilities, I think, are working in favor of Earth not being very lonely.
With every new planet found, Earth has gone from being a sort of only child to being part of a huge, ever-expanding extended family.
And we can say really confidently that every stinking star you see in the sky has a family of planets orbiting it.
And now, as the James Webb Space Telescope and other ground telescope arrays begin to release data, our understanding of what's out there will reach a whole new level.
I mean, who knows what these telescopes are going to see? It's going to be wild. It's going to be wild.
So now that we know there are so many planets, the corollary question, do any of them contain life, has become a research inevitability. Federal funding is finally becoming available, and a private initiative called Breakthrough Listen is putting $100 million behind a massive search for life in the cosmos. And this is great news for the new generation of SETI scientists who are now rolling up their sleeves. Okay, all right, so let's just get down to brass tacks, Sophia. I got to ask you this question. So how long have you been looking for aliens?
I have to do some math. I don't have that off the top of my head. 6, 7 years.
Sophia Sheikh was the very first undergraduate researcher at Breakthrough Listen and is now a postdoctoral fellow working at the SETI Institute, a research nonprofit. She's about the same age as Frank Drake was when he first climbed up into that radio telescope.
The way that he approached it was he had a receiver that could only look at basically one channel at a time and listen and see if there was any super loud signal coming, and then he'd check the next frequency. Just tuning through the radio dial on your car, basically listening to see if there were any signals coming from space. Now we can do 1 billion channels at a time. Multiple billions of channels at a time.
Wait a minute, 1 billion channels
at a billion.
Oh my God. Wow.
The rate that we can search is so much faster now that even in just a single night of observing, we can cover what took years to do in the 60s and 70s.
So how do you actually leverage the technology that's possible to do any sort of, listening?
And that's the big question. You've hit the nail on the head there, in that, okay, you get 1 billion channels at once. How do you pull the interesting ones out? And that's where algorithms and big data and large computing clusters come into the problem.
Sophia is searching for signals, which are now referred to as technosignatures, signs that a planet has technology. Other scientists are looking for biosignatures, which means planets that support any kind of life, no matter how primitive.
And so they're very closely related concepts. Either way, you've detected life in space, and that would be incredible, right?
So, do you feel like at least, statistics are on your side? Like, it's out there, it's got to be out there, We just have to look and find it.
For me, personally, I think it would be kind of contra everything else we've learned about the universe for us to be the only technological civilization or the only life in our galaxy or universe. That would be weird.
Sophia isn't alone in her thinking, and her fellow SETI researchers are no longer toiling in obscurity. The days of the giggle factor may at last be behind them. And the future? Well, that's about to change too.
I think what people need to understand is that we are standing at the edge. You think about it with the Polynesians and their amazing voyages across the the Pacific. The boats are on the shore. We're loading them up right now. We've got technologies that we've never had before, and we're just pushing off. People need to understand how radical a moment this is.
Like another radical moment back in 1960 when a call went out to bring a group of scientists together, Sophia Sheikh recently reached out to her colleagues to make a connection in a field that's dispersed all over the world.
And so it started as a group with maybe 8 people. And now I think we're up to around 30, 35. That really just made it feel a lot less lonely.
Just as Frank had, Sophia brought scientists in the field together. But this time she did it via Discord, a messaging platform. And as a nod to the Order of the Dolphin, her group called themselves the Order of the Octopus.
We ended up picking the octopus because, in a way, it's one of the most alien forms of life that shows kind of problem-solving abilities.
Their mascot, a non-mammal with a non-human form of intelligence, serves to remind them of what it might mean to make contact with what's out there. The basic human need to connect, either by reaching across a scientific discipline or across the entire universe. It runs deep for Frank Drake.
The search for life beyond Earth is all about connection in some way, right? We don't do well in isolation. When Dad started thinking about SETI, he just really wanted to know if there were other beings like us out there that maybe we could connect with.
But in the evolution of the field, which now pursues a range of answers about the existence of life in the universe, the same basic question still drives the work. Is Earth the only place where life is developed? Or does it also happen elsewhere? Frank has spent a lifetime searching for an answer.
Unfortunately, we've never captured anything from space that looked as though it had information on it about other creatures.
But that doesn't deter Sophia Sheikh, with whom he shares the very same goal.
I do think that by the end of my career, with the speed that we're able to search now, we should have a pretty good answer on whether anyone else has built a radio transmitter. And every time we don't find something, that's still information. It's not a waste of time.
Frank Drake never said it would be easy, or that it would happen quickly. But continuing to ask the question has paid off in dividends. It's yielded scientists like Nadia Drake, Adam Frank, Sophia Sheikh, and multitudes of others who've learned that when it comes to space, the only way to answer the biggest question of all is to do the science and to play the long game. How do they know? Frank Drake taught them.
Those who do feel that the goal justifies the great amount of effort that is required will be carrying on this research, and there's a good possibility that sometime in the future, and we don't know how long that will be, maybe 100 years, maybe next week, this search will be successful.
If you like what you hear, please consider a National Geographic subscription. You'll get exclusive access to the stories published daily, curated newsletters, and 130 years of archives. Subscribe today at natgeo.com/explore more. For everything about exoplanets, including daily discovery updates, check out NASA's incredibly cool website. You also don't want to miss images arriving from the James Webb Space Telescope, which came online last month. And you can read an article by Nadia Drake about another groundbreaking radio astronomer named Dame Jocelyn Bell Burnell. In 1967, she discovered the first radio emissions from a pulsar, but her advisor won the Nobel Prize for her discovery. Go figure. Visit the observatory in Green Bank, West Virginia. You can see the Drake Lounge, where the famous equation was unveiled. For you history buffs, the cool mid-century furniture is still exactly the same. And special thanks to the National Radio Astronomy Observatory, who provided the audio you heard of Frank Drake in 1960. The speech was part of the Sullivan Papers in the AUI archives. This week's episode was produced by Marcy Thompson. Overheard is produced by Kyrie Douglas and Alana Strauss. Our senior producers are Brian Gutierrez and Jacob Pinter. Our senior editor is Eli Chen. Our manager of audio is Carla Wills. Our executive producer of audio is Devar Ardalan. Hansdale Sue sound designed this episode and also composed our theme music. This podcast is a production of National Geographic Partners. Whitney Johnson is the Director of Visuals and Immersive Experiences. Nathan Lump is National Geographic's Editor-in-Chief. And I'm Peter Gwin. Thanks for listening, and see y'all next time.